Hello, friends. Let's talk about Newton's third and final law of motion, the law of action-reaction. So to start with, Newton's law of action-reaction says this: for every action force, there is an equal and opposite reaction force. First, you need to understand that all forces act in pairs. When things interact, they create an action-reaction force pair. The action force is the force exerted by one object, and the reaction force is the force exerted by a second object, except that force is equal in amount and opposite in direction to the action force. So, for example, object A exerts a force on object B, and object B exerts a force that's equal in size and opposite direction back on object A. Here are some examples to look at here. Okay, so we have a kid pushing himself on a skateboard. The action force here is him pushing against the ground, and the reaction is the ground pushing back on him. I know that sounds a little weird that the ground is pushing back on him, but it's true. So this is a force pair. They're equal in size, but opposite in direction. The action force is going this way, the reaction force is going this way. In this example, we see a boy pushing on a wall, and the wall is exerting a force on the kid that's equal in size and opposite in direction to the force that the kid is pushing on the wall. In this example, we see a book on a table, same thing. Here's a force pair. The book is applying an action force to the table, and the table is applying a force to the book that's equal in size and opposite in direction. So object A exerts a force on object B, and object B exerts a force on object A. They exert forces on each other, but they create a pair in the process. So if forces are equal, then how do objects move in one direction or another? Well, that's a really valid question. So the motion of an object is actually not determined by the forces that it applies to other things, but rather the object's motion is determined only by the forces acting on the object itself. Another thing that comes into play is that when objects interact, the forces they apply to each other are equal, but their masses are not usually. The more mass something has, the less acceleration it will experience, and the less mass something has, the more acceleration it will experience. We know this to be true from Newton's second law. So let's take this example to kind of think this one out. So we see a baseball player hitting a baseball with a bat. We know that the baseball is going to go flying off in a different direction, right? And that's because the mass of the ball is much less than the mass of the bat. So even though the ball and the bat each apply a force to each other, the forces are equal in size but opposite in direction, the mass of the ball is so light that it causes its acceleration to be greater than the bat. So therefore it changes direction. And that's it. That's Newton's third law of motion. Just remember, equal in size, opposite in direction, action-reaction force pairs.